My name is Kokula Connection. I am from University of Uttar Malaysia studying Information Technology course. I am here today to give you a better explanation about one of my subtopics from my Discrete Structure class. So, are you ready guys? Let's go. So, the topic I am going to explain is about sets. What is sets? Sets are a collection of elements, or set is a collection of well-defined and distinct objects. For example, we have a list of gadgets such as computer, laptop, phone and headphone. So these are the elements of the gadgets. The next example is foods such as vegetarian and non-vegetarian. So these are the elements of the foods. All the elements in a set should be related and well defined. For example, there is no such good or bad gadgets. It is different in everyone's opinion, and there is no such good or bad foods. Every food has its own benefits. So, how do we represent sets? For example, set A, which elements of A, B, C, D, E, and should be covered with braces. In sets, ordering of elements is not important. For example, A following B following C is equal to A following C following B, and is equal to B following C following A. Capital letters are used to denote sets. For example, set A with elements of 1, 3, 5, and the condition is an odd number and less than 6. So, we have the symbols that shows which is an element of and which is not an element of. For example, set A with element of 1, 3, 5. So 1 is an element of A and 6 is not an element of A. Next is empty set. Empty set is a set without any elements. So this is a symbol of the empty set. Sometimes it is impossible to list down all the elements in a set. This is because the condition of the element. For example, set A with the element of 1, 3, 5, dot dot dot. That means it continues. It cannot be listed down until the end. This is because the condition of the set which is positive or numbers. So which is lead to the infinity. There is no possible to list down all the elements. So the next is subset of. What is subset of? For example, set A with element of 2, 3, 4 and set B with element of 1, 2, 3, 4, 5. And A is the subset of B, which means all the elements in A are also in B. The next example is set A with element of A, B, C and set B with element of 1, 2, 3. Therefore, set A is not a subset of set B. So, how do we illustrate sets? Using Venn diagram. Venn diagram consists of universe, sets and intersection.
Next, we are going to see finite sets. Finite sets has distinct elements, or finite set has a finite number of elements. N is an element of natural number, where n is called cardinality of A. And for the infinite set, which is opposite of finite set, where infinite set has the infinite number of elements. Next, we are going to see the power set. What is power set? For example, set A with element of 1, 2, 3. And all subset of A is called the power set of A and is denoted by PA. Then PA, which means the power set of A consists of all the following subsets, such as empty set 1, 2, 3, 1 and 2, 1 and 3, 2, 3 and 1, 2, 3. These are the basics you should know about sets. So now I'm going to give 3 questions to test your understanding about basic concept of sets. You will be given 10 seconds to find your answer. Let's go. Now we are going to see the operation of sets such as union, intersection, complement and symmetric difference. For the union is a set consisting of all elements that belong to all sets in form. For example, set A with element of 1, 2, 3, 4, 5 and set B with element of A, B, C, D, E. And the union of set A and set B is equal to element of 1, 2, 3, 4, 5, A, B, C, D, E. This means all the elements of set A and set B are merged together or added together. For the intersection is a set consisting of all elements that belong to both sets in form. For example, set A with element of 1, 2, 3, 4, 5 and set B with element of 2, 4, 6, 8. And the intersection of set A and set B is 2 and 4. Elements 2 and 4 are in both set A and set B. So for the complement, let's say B with respect to A can be defined as the set of all elements that belong to A but not to B. For example, set A with element of 1, 2, 3, 4, 5, 6 and set B with the condition of x square less than 16. So the B with respect to A is equal to 5 and 6, where the elements of set A, which is 5 and 6, is not matched to the condition of set B, which is x square less than 16. If U is a universal set containing A, then U minus A is called the complement of A. It can be denoted by A complement. The last operation of set is symmetric difference. Symmetric difference is defined as the set of all elements that belong to A or B but not to both A and B. For example, we have a set A with element of 1, 2, 3, 4, 5 and set B with element of 2, 4, 6. So the symmetric difference between the set is 1, 3, 5, 6. Stay focused. Now we are at the last part of our subtopic of sets. So this is the addition principle. In this addition principle, there are three theorems that can be applied to the finite sets. That means we cannot apply this theorem on the infinite sets. For the first theorem, A union B equal to A plus B. This theorem can be applied if each element in A union B appears in either set A or set B but not in both. For example, set A with element of 1, 2, 3 and set B with element of 4, 5, 6 where set A and set B are disjoint sets. So the second theorem is A union B is equal to A plus B minus A intersect B. This theorem can be applied if the element in A intersect B belong to both sets. The sum A plus B counts the elements twice. To correct this double counting, we subtract with A intersect B. This theorem too was introduced as inclusion-exclusion principle. So for the third theorem, which is similar to the second theorem, but what if there are three sets? We will use the final or the third theorem of addition principle, which is A union B union C equal to A plus B plus C minus with A intersect B minus with B intersect C minus with A intersect C plus with A intersect B intersect C. For the better understanding, let's see how these theorems are applied to the Venn diagrams. Yeah, these are the basic concepts, operations and addition principle of subtopic for the set. So hope you guys understand and thanks for watching.